Okay, so lesson 18. This is the first video of the lesson for today. We're going to get into y equals mx plus b today, one of the most important parts of mathematics and linear equations. We're also going to talk about graphing with intercepts today. And then we're going to begin today's lesson talking about some review type of questions, some review of our lesson the other day, which really leads into today's lesson, and also some work with some review questions from the recent past. Okay. First question, let's do a stop and start. Do a little work with some isosceles problems here. Okay, so the two legs of an isosceles triangle can be represented by 4n minus 3 in parentheses and 2n plus 6. Find the length of one of the legs. So remember from this diagram that in an isosceles triangle, the two legs are equal. That's the little hash marks there. And since they're equal, I set up an equation where they're equal. Distributing the 4, subtracting 2n from both sides. That leaves me with 2n minus 12 equals 6, adding 12 to both sides. 2n is 18, dividing by 2, and n is equal to 9. Okay? Does that answer the question? No. It says find the length of one of the legs. Oh, what is it asking for? Mr. Braze would always say. Well, the length of one of the legs is going to be 4 times 9 minus 3 in parentheses, or 2 times 9 plus 6. 2 times 9 plus 6 is 24, and 4 times, in parentheses, 9 minus 3 is also 24. So when we get into isosceles triangle questions, we can ask about the legs or we can ask about the angles. We have to be prepared for both eventualities. So as I look at, it says in this problem that the base angles are each 20 more than 3 times the vertex angle. Okay, so there's n for the vertex angle. And I didn't change this. I apologize. I messed up. It shouldn't be 20 more than 3 times the vertex angle. I should have changed the wording here to be 9 less than 4 times the base angle. So why don't you stop the video at this point in time and go forward, and let's do the n, the 4n minus 9, and the 4n minus 9 as the 3 angles. Do stop and start. I'll start it up in a minute. Okay. So those 3 angles in the diagram, not in the wording, must add up to 180. Same side, same operation. 1n, 4n, and 4 more n's is 9n. Minus 18 is 180. Add 18 to both sides. 9n is 198. Dividing by 9, and n works out to be 22. Now it wants the measure of a base angle. 22 is the vertex angle up at the top. The measure of the base angle is going to be 4 times 22 minus 9. That works out to be 79. And just for good measure, to make sure all the angles add up to 180, 22 and 2 angles that are 79 each, they do add up to 180. Okay, a little stop and start also on a consecutive integer problem. Go ahead. Okay, so I underline the most important parts, as you should too. It says consecutive odd, and we know that whether it says consecutive odd or even, they both go up by 2's, so that's n plus 2 and n plus 4. And then I love to write the words. Twice the first, 2 times the first, plus twice the second, and 3 times the third equals 93. So the first is n, so twice the first is 2n. Twice the second is 2 times n plus 2. And 3 times the third is 3 times n plus 4. Distributing that, it's 2 times n plus 2 is 2n plus 4, and 3 times n plus 4 is 3n plus 12. The 2n there, same side, same operation. Combining like terms, I get 7n plus 16 is 93. Minusing the 16, I get 7n is 77. Dividing by 7, 7's running wild here. N is equal to 11. But I still didn't answer the question because it wants find 3 consecutive odd integers, and those are 11, 13, and 15. Okay, so those review some word problems and some geometry problems of the recent past. Now let's talk about some work that we did just the other day. And what we worked on the other day was completing a table and then graphing the line that we get when we complete the table. So you can do this now on your own and complete the table by doing some calculations, or you can do it in the graphing calculator. But you establish whatever you want the domain to be. Remember, the domain is the set of all inputs. It's the x's. You fill them into the box. You either calculate or use the graphing calculator to figure out what the y values are and then graph. We'll do stop and start, and then I'll put it up. Go ahead. Okay, so I'm going to use -2 to 2. I like that because it keeps it centered in the middle of the graph. There is no other reason to do it. If I made a bigger graph, I wouldn't necessarily stick to -2 to 2. And let's see, let's calculate the y values. So -2 times -2 is 4, plus 2 is 6. -2 times -1 is 2, plus 2 is 4. -2 times 0 is 0, plus 2 is 2. -2 times 1 is -2, plus 2 is 0. And -2 times 2 is -4, plus 2 is -2. And of course, you could have entered under y1, under y equals in the calculator, y1, -2x plus 2. And it would literally have this segment of, if you went to the table, this segment of the table would be reproducible and you could fill in the values, or any section of the table that you like. Again, I like this section because it fits in the middle of the graph. Plotting the points, there's -2, x is -2, y is 6, -1, 4, 0, 2, 1, 0, and 2, -2. Play connect the dot, bingo, graph is done. Now the next one we go into teaches us a little further refinement. If I'm going to put a fraction in front, I'm going to want to choose domain elements, x values, that are divisible by that denominator so that I get whole number answers. If you put these numbers into your calculator, you'll notice that you get whole number, decimal, whole number, decimal, whole number, decimal. Just skip the decimals, don't graph them. Just graph the whole number ordered pairs. And that way it's nice on your graph. And when you draw the line, you'll actually be going through the decimal parts with the line. Okay, stop and start. Go ahead. Okay, so I'm going to go -4, -2, 0, 2, and 4. And again, I chose those answers or those domain elements because I have to divide by 2 each time. And with even numbers, that'll come out to be a whole number and not a decimal. So -1/2 times -4 is going to be 2 plus 3 is 5. -1/2 times -2 is 1 plus 3 is 4. -1/2 times 0 is 0 plus 3 is 3. -1/2 times 2 is -1 plus 3 is 2. And -1/2 times 4 is -2 plus 3 is 1. Now we plot the points. -4, 5, -2, 4, 0, 3, 2, 2, and 4, 1. That works out to be, when I connect the dot, the correct graph of that line. So that's the second type of problem that we needed to really understand. What do we do when we get a fraction? We need to understand that the domain elements that we choose, the x values, should be divisible by that denominator. And the last thing that we worked on the other day is we worked on, in lesson 17, what happens when we get something like this, 2y minus 3x equals -2. And what we realized is we have to make sure that we, oh, excuse me, I have to yawn. We have to make sure we get it to say y equals. So the first thing I do is a little work with the literal equation. 2y minus 3x is -2. To get the y all by itself, to make it say y equals, I first add 3x to both sides. And then I divide by 2. And I get y equals 3/2 x minus 1. Notice there is a fraction here, so I want to pick y values that are divisible by 2. X values that are divisible by 2. 3/2 times -4 is going to be -6, plus 2 is, minus 1 is -7. 3/2 times -2 is going to be -3, minus 1 is -4. 3/2 times 0 is 0, minus 1 is -1. 3/2 times 2 is 3, minus 1 is 2. And 3/2 times 4 is going to be 6, minus 1 is 5. I plot the points. Okay, there's -4, -7, -2, -4, 0, -1, 2, 2, 4, 5, and connect the dots. Bingo, there's the correct graph that I'm looking for. So that is a review of the skills of the other day, plus some recent word problems.